Welcome to the first demonstration of Smart BMS. So there is a battery management system along with active cell balancing by using Raspberry Pi 4. So here the main application of this project is we are continuously measuring the battery voltage as well as temperature using this DS18-bit temperature sensor. So this battery pack 1, battery pack 2, battery pack 3. So these three battery packs continuously monitored by the PIC microcontroller. So we have interfaced these three battery packs to the voltage sensors to the PIC microcontroller. So we are using the PIC microcontroller to convert analog to serial conversion. Means as the Raspberry Pi doesn't consist of inbuilt A to D converter, means inbuilt analog reader. That's why we are making use of this PIC microcontroller which will measure the battery voltages continuously and which will convert that analog data to serial data and will that provided to the Raspberry Pi directly. And we place the load here to check the SOC and SOH values of these battery packs. So here the battery pack voltages is nothing but battery pack 1, 2, 3 will be fed to the Raspberry Pi and it will process the voltages, and if the battery voltage is rapidly reduced, means if the voltage drop was more than the normal battery ratings, then the SOH values will be affected and that will be calculated and displayed on the 16:2 LCD screen continuously, and SOC also. So whenever the battery voltage is less, so then the system will trigger the microcontroller to control these three relays which will connected the voltages between these three packs only. Means instead of connecting the charger, the system will transfer the voltages between these three battery packs. So battery pack 1, battery pack 2. So if the battery pack 1 is less than the battery pack 2 voltage, then the voltage between these two will be transferred and make the all three battery packs same level of voltages. And external charger is provided from this transformer through this charging circuit here. So mainly the inputs are battery packs through the voltage sensor to the microcontroller, and temperature sensor is the main input to this one. Whenever the abnormality detected, the system will provide us the audible through the buzzer, and the same data displayed on the 16:2 LCD screen, and same will be uploaded to the ThinkSpeak, as the Raspberry Pi consists of inbuilt Wi-Fi. And these three relays are the output modules to make the active cell balance in our project. So here let us check the demonstration. So these are the previous data while we testing of this one. So when we just click on that, then we get the SOH values along the date and time here. And the battery pack 1 voltage, and battery pack 2 voltage, battery pack 3 voltage and temperature. So these are the continuous parameters are uploading to the ThinkSpeak. So before demonstration, just on the hotspot in your mobile phone. So configure the hotspot name to project 7511 without any space, without any capital letter. Password should be 123456789 and the AP band should be 2.4 gigahertz. After enabling this hotspot along with the data, we log into ThinkSpeak. So once we log in, then we get this data page. This is my channel. Just click on that. They get the previous data here. So if you want to erase the old data or if you want to download the data, before erasing, better take this data backup. So for the data import exports, and now download the data. So it will be downloaded in Excel sheet. Once the data downloads successfully, there we can see the data in Excel sheet, which consists of date and time and number of samples till now collected. So date and time and how many samples till now collected. We can see that. So 48 samples. First one is the temperature, battery pack 1 voltage, battery pack 2, battery pack 3 voltages and SOC, SOH values. So once we took the backup, now go to channel settings to clear the channel. So in that only do clear the channel, don't delete that. So once the channel got cleared, it will pop up, and now go to private view. So there you get the old data got erased. Now after these successful settings done, so you can erase the data or you can keep the data as it is. The fresh data will be appending to the existing old waveforms. Now on the power supply to this one, and on the power supply to the transformer also. So if you on the transformer, the voltage will be charging to the battery pack to this relay. So if you off this transformer, the active cell balancing will be done. So it will take around 20 to 30 seconds of duration logging to the operating system. Right. So one logging successfully done. Wait till the stabilization will be done. Right. and for every 10 to 15 seconds duration the data will be uploaded to the ThinkSpeak. So as of now everything is normal. So we can see the battery pack voltages as well as SOC, SOH values will be monitored over here. So SOC values will be calculated. It will take some time as it need to check the battery voltages. Right, so we got the values in ThinkSpeak. Temperature, 1 voltage, 2 voltage, 3 voltage of the battery packs and SOC, SOH values. Right. So meanwhile, if we increase the temperature, just we can use the external heater to make the temperatures are heating up. As the temperature will rises, right. So when it crosses the 40 degrees centigrade, then you get the audible alerts through the buzzer continuously. So when the temperature coming to normal, then the buzzer will be off and everything will be normal condition on the LCD. So here coming to the SOC value, whenever we disconnect the battery pack 1 voltage to the voltage sensor, then the system will indicate it is the very less voltage. Then the relay gets switched on to transfer the voltage from these batteries to the low battery voltage. There we can get the SOC values will be calculated. As the battery voltage is very less, that's why we are getting the SOC values and SOH values are very less from the 95%. When it is above 95%, then everything is normal. So this is the case of error when we make the battery pack 1 voltage low, and when it is normal again, so it will be reconnected. Means it will disconnect it to the battery packs. And if you make the battery pack 2 voltage very less, then this second relay will get switched on as indication of the battery voltages will be interchanged between these battery packs. That is the active cell balancing. Same in case of third battery pack also. So when this relay gets switched on, the battery voltage is connected from the high voltage batteries to this low voltage battery pack. Okay, so when we connect this to the transformer, means when we on the transformer, then this light indicated, then the battery will get charged from this to the reverse AC input instead of doing the active cell balancing. So this project consists of charging voltage from the charger and also interchanging of voltages between the battery packs by using the active cell balancing. So that will be achieved with the help of our Raspberry Pi 4 here, and continuously the status of the monitoring will be done on this LCD, and the same data will be uploaded to the ThinkSpeak continuously. So just when we click on the dots, there you get the details along with date and time. At the same time we are going to get the details. Okay, and the same like temperature also. Whenever the temperature increased, right, so when the temperature is above 42 degrees centigrade, then that is the abnormal condition, so that the system will provide us the audible alert through the buzzer. And when it is coming to the normal, right, and buzzer will be off. Same like this DC motor also. So it's continuous process till we disable the system keep on uploading the data to the ThinkSpeak cloud platform directly. Right, okay, thank you.